Okay, so how did you do? Did you have any idea what we mean by the additive inverse? This is problem number 5.
I think I do.
Okay, Brian?
You switch the signs, so it'd be like
Exactly.
it'd be 3 minus 5.
Another word for additive inverse is opposite. So if you want to write opposite up there to remind yourself, that is another word for additive inverse. It's opposite. So for A, problem A, 5A, you should have 3 minus 5. And for B, you should have negative 16. Negative 16. Okay. Number 6. Did anybody get 6A? Tell me what you got, and we'll talk about whether it's right or not. Anybody got it? Simone?
12x squared plus 6xy.
12x squared plus 6xy. Did I write it right? Okay. What do the rest of us think, class? Do we think she knows what she's doing? I see some thumbs up. That's perfect. Now, what about B? Very good, Simone. What about B now, though? B looks different. We're actually going to do the distributive property in reverse, which means we're going to factor it, right? We're going to factor it. So instead of putting a number in, we're going to pull a number out. So what can I do to factor problem B? Take out an x. And what do I have left if I take out an x, Miss Rutland?
You have 5x minus 8y.
That sounds good to me. How about the rest of you? Are you good with that?
Yeah.
Notice that is easy to check because all we have to do is multiply it back in order to check our work, right? So we should probably get in the habit of doing that. Okay, what about C? Anybody have a thought about that one? Max? Nope. Johnny?
Yeah. I took out A2Z.
Took out A squared Z. And what were you left with?
A plus Z to the 4th.
All right. What do we think about Johnny?
I like that.
We like that?
Yeah.
Anybody have a question about it? All good? All right. D. Who's got a suggestion for D? Mr. Lee?
10x cubed minus 6, minus 6x squared, y, whatever you say that.
Is that what
Yeah,
you want me
yeah,
right?
yeah.
Okay, what do we think, kids? Is that right?
Yes.
You okay with that? All right, 2 more. How about E? Anybody get an answer to E? That's got some big numbers in it. Trey?
I got 32 parentheses 5a minus b.
Wow, what do you think, guys? I think he's right.
I'm gonna trust him on this one.
I think he's right. Now, I don't know if he used his handy calculator, maybe he didn't need it, but if we do 160 divided by 32, it actually goes in evenly 5 times, so we can take out that 32. He's good. Good job. And the last one, what is it? I heard a negative 6x, I think,
Plus 21y.
and a plus 21y. Now, when we're doing this together and you're really focusing, it's so easy. But I can't tell you how many times people forget this. Remember, if you are distributing a negative, it goes to everything, right? This is correct. This is absolutely correct. But try to remember that. Okay, perfect. All right, did anybody get to number 7? And start with the exponents.
I think I know.
You think you know.
I think it's x over y.
Well, let's take a look at it and see. You know what? I think you're right. Let's talk about why you're right. If you really think about what this part of the problem is saying, you have 3 x's on top of 2 x's, right? And this will cancel with this, and this will cancel with this. So what's left?
One.
Just 1 x, and that's what he's got. So bottom line is, I got 3 on top, 2 on the bottom. They're going to cancel. I have 1 extra left over on the top, because the top is 1 bigger. Now we can do the same logic here. I have 4 on the top, 5 on the bottom. Who's bigger?
Bottom.
The bottom. How much bigger? 1. So you have 1 Y on the bottom. Perfect. Now B is not quite as easy.
Don't you multiply it by itself, or would it be like 3 times -2? Would it be 3 times a -3 on the top, and then like X, Y?
Okay, you are saying, where's my seating chart? You are saying some really good things there, and you got 2 great ideas, but you said them kind of inverted there a little bit. So let's talk about this for a second. Does anybody remember what a negative exponent does to a fraction like this? Okay, now Max.
Is it the reciprocal?
It flips it, that's exactly right. So when you put a negative exponent on a fraction, and that's what's happened here. When you put a negative exponent on a fraction, it's going to flip your fraction. So step 1 is gonna be, we're gonna flip that fraction, and now the power is just a plain 2. When you flip the fraction, that's how you make the exponent positive. Now, everything in there is gonna be squared. So obviously, we're gonna have x squared, we're gonna have y squared, and we're gonna have what on the bottom? 9, 3 squared. There's your answer. I would suggest, and math can be done lots of different ways, but I would suggest that you take care of negatives first. If your problem has a negative exponent, deal with it, okay? All right, let's look at the next one. Oh, 9, okay. All right, this one doesn't have any negative exponents, so I don't have to worry about that. But it does have a parenthesis squared. So let's take care of that. Okay, I see some of the same hands going up, which is awesome. Do I have any new participants? Okay, Max, do it again. What do you want to do here?
It could be 16x to the 4th power.
So he says 4 squared is 16. X squared squared is x to the 4th. We've got these properties of exponents. Yeah, that is a multiplication right there. But if you forget or get confused, remember x squared squared means this, right? And that's how many x's altogether? 2 here and 2 here, that makes a total of 4. So even if you forget your properties, or if you're a little confused, or I add, do I multiply, what do I do? You can always kind of write it out and figure it out. But that's right. Okay, so now we're here. Now I think we can start simplifying. What happens with our numbers? Divide. 16 divided by 4 is 4. Now let's look at our x's. How many x's are on the top? 4. How many are on the bottom? 2. Who has more? The top. How many more?
2.
So we got x squared on the top. And then, and we don't really need this. So 4x squared y to the 5th. You're thinking you're all pretty cool and all that. Okay, let's look at the next one. This might pop your bubble. I don't know, it's kind of hard. What's kind of hard anyway? Okay, so what do you think? Disagree?
Put the negatives in the, or like swap.
Take care of the negatives, that's right. A minute ago I said I really feel like that's the easiest way to handle these problems, is if you have a negative, fix it. Okay, so what do we mean by fix it? just what he said. Now, we're not flipping this whole fraction. It's not the fraction to a negative, it is this x to a negative. So he moves, just him, he's gonna move to the bottom. So I'm gonna have an x squared down there. Same thing with this, I'm gonna have a y cubed on the bottom. What about that z?
Stays.
He stays. This one stays. What about this guy, this y? Up. And he stays. So take care of your negatives first. Now start fixing it. These x's aren't gonna cancel. Notice they're both on the bottom,
Add 'em
right?
up. Yeah.
So I got 4 of them and 2 of them, so altogether I got 6 of them. Now the y's are gonna cancel. They cancel when they're on top of each other. So I got 5 over 3. So that's gonna leave me with 2 on the top. This is the same, this is gonna cancel now. That's z to the first. So 1 on top, 6 on bottom will leave me with
0 to 12.
5 on the bottom. Remember, we do not want negative exponents. So it's okay to subtract, but then you have to deal with that negative. So it's z to the 5th on the bottom. Oh, I think e is kind of easy compared to this. What's e gonna be?
X to the 6th over 27.
X to the 6 over 27. Can't fool you guys. How'd we get 27?
3.
3 cubed. 3 times 3 times 3. You're cubing here, including the 3. So 3 cubed is 27. Okay, and finally, last exponent.
I have a question.
Huh?
On these, since when we flip them, would it be x over 2 times 2 over x, or x over 2 times x over 2?
Good question. You're gonna flip this guy, then x over 2 squared down,
Yeah.
which means x over 2 times x over 2.
Okay.
There's no more flipping. You flipped one time, your exponent's positive, so that's it.
Alright.
So our answer will be
Zero.
x squared, not 2x, x squared over 4, right. When do we get 2x? When we add x plus x. Yeah, x plus x would be 2x. Okay, now we're moving on to scientific notation. I presume by this stage of the game, you've all had chemistry. Is that a correct presumption? That we've all had some kind of chemistry? And you've done, in chemistry, we deal with great big numbers, little tiny numbers, and so we have this thing called scientific notation. Does anybody remember how it works? You remember what it looks like?
Isn't that like, oh, sorry,
Someone, I don't care.
oh, is that like when you do like 300,000, or what's that, like when you write it all out in its own,
Okay, that is this. Okay, this number is written out in standard notation.
Don't you time something by like 10 or 100?
Yes, by 10, powers of 10. So scientific notation is something times 10 to a power. You remember that? Something times 10 to a power. Now, it's very, very simple. To find the something, you move the decimal point. In this problem, that's the decimal point right there. You move it till it gets to here. When you write your something here, it has to be one number in front of the decimal point. Not 6 numbers, one number in front of the decimal point. So I have to move this 1, 2, 3, 4, 5 times. So my answer in scientific notation will be 3.14683 times 10 to the 5th. Why is it times 10 to the 5th? Because that's how many times I move the decimal point. Is it starting to come back to you now?
Yeah.
So 0.7136. Step 1, move the decimal point. And this time it would have to move right here, right?
Yeah.
That would give me 7.136. This is how your number has to look. Something point. One number point. Times 10 to the what? Negative 1. Very good. Now, when you learn this, you may have learned it using the ideas of, right is this way, left is that way. I just remember that big numbers have positive exponents and little numbers have negative exponents. So 0.7 is a little number, 314,000 is a big number. Okay? Now we're gonna do some arithmetic with scientific notation. So you might use your calculator to help you here a little bit, but here's how we're gonna do this. We are going to do the problem in 2 parts. Because scientific notation is really 2 parts. Scientific notation is this number part, and then all of the tens. So we're gonna do the blue part, and then we'll do the pink part. All right? So let's take our calculator out. And let's multiply the 3.16 and the 1.43 and divide by the 1.23. Does that make sense to you that that's what I would do? Multiply these two and divide by that one. Okay? Now I got some big ugly number because I didn't plan this very well. So I'm gonna have to round it off. 3.674. How does that sound? 3.674? Can you live with that? Now I need to deal with the pink part. I need to figure out how many tens I have. So in the problem, I'm going to look at just my tens over here to the side. I've got 10 to the 5th times 10 to the negative 8 over 10 to the negative 10. Would everybody agree that those are the tens? The pink things I've got. Okay, we don't like negative exponents, so let's move some things around. 10 to the 5th. 10 to the 8th comes down, and 10 to the 10th goes up. How many tens are altogether on the top? 15? So what happens when I have 15 tens over 8 tens? Think about canceling. What's going to be left over? 7 of them on the top, so 10 to the 7. And there's the answer to the question. Now, take a moment and try the second one. It is much easier.
So what was the import to that again? Why is it to the 7?
Because when I put these together at 15, so I have 15 on the 15 tens on the top.
Okay.
10, 10, 10, 10, 10, 10, 15 of them. I have 8 on the bottom. So when I start canceling them, what's going to happen? 7 left over.
Okay.
I hope you're multiplying 3.85 times 4.96.
Yeah.
And I got 19.096. Is that what you got?
Yes.
And then how many tens have I got? This one's easy. I got 10 and 13, that's 23. So how many of you got that as your answer? Guess what? We're not done. This is a trick question. This is correct. This is absolutely correct, but we're not done with it. Can anybody see what's wrong with it?
Oh,
Yes, Johnny?
Decimal.
The decimal's in the wrong spot. Now, we can't help that. This is what you get, okay? But it can't be your final answer. So now you're gonna have to move that decimal point one place. So it's gonna become 1.9096 times 10 to something.
24.
Now, it's either gonna be 22 or 24. Would everybody agree with that? We moved it one place?
Yeah.
I don't know how 24 is correct. So those of you that think it's 24, you are dead on. Here's how I remember, or I think of it to get that 24. I know that this is my answer, but I have to make it in correct form. So these two have to be equal. Since this number got smaller, I went from 19 down to 1.9. To keep everything balanced, this one's gonna have to get bigger. Because these two numbers have to equal. Keaton, are you with me, honey? Okay. You look bored, and I know you can't possibly be bored. Because after all, we're in math class, right? Okay, let's look at our properties. I want you to look through those A through H. Do you know any of them? A through H? Don't just sit there. I know you're in lunch coma or whatever you call it. You know some of these.
Is D just addition?
Is D just addition? Well, it is a property of addition. D is actually called the additive identity. Why is it called that? Well, what happens when you add 0?
Nothing.
Nothing. You get the same thing back, the identical thing back. When you do something and it doesn't change the answer, it's an identity. So if I'm looking at this, look at it carefully. There's another identity on here. F. F is the multiplicative identity because multiplying by 1 doesn't change you. So adding 0, timesing by 1, those are identity properties. Alrighty? Alright, do you recognize any others?
A
A
distributed.
is distributive, yeah. A is definitely distributive. And there's one more distributive too.
the one below it?
Nope, not the one below it.
H.
It's H. H is distributive. H is one of those that's like distributed backwards. Factoring problem. Anytime you factor, you're doing distributive. Okay? Alright, let's talk about, let's
Isn't there like a additive inverse or something?
There is. There
That's
are
additive
inverse
inverse.
properties. Now, I do not have an example of the additive inverse, but I'll write you down one. This would be the additive inverse. This would be an example of the additive inverse. Inverses cancel each other out. So if you add 8 and negative 8, you get 0.
Isn't that
They
from
cancel each
5?
other out. What?
Isn't that from 5?
Yeah, yep. Finding the additive inverse, yes. There is a multiplicative inverse on this list. Does anybody see something happening where they cancel each other out?
Or
G. G. G is your multiplicative inverse. Because when you multiply reciprocals together, they cancel each other out. Now, what does that leave us with? B, C, and E. All right, so I want you all to look at problem B. Read the left side, read the right side. What changed?
The order of the stuff.
The order, right there it is, the order of the x and the y. This is called the commutative property. And this particular one is for addition, the commutative property of addition. Now, here's how I want you to remember this. What does commute mean?
Move.
Move. It means get from point A to point B, right? Move. If the numbers in the problem or the letters in the problem are moving, didn't the x and y move? When that happens, it's commutative. So the x and the y moved. Commutative property. Now let's look at C. What changed in problem C? The 6 moved, didn't it? So guess what? That's another commutative. That one though is not addition, it is multiplication. You can abbreviate. It is multiplication because it's one side is 6 times and the other side is times 6. Multiplication. All right, let's look at E, last one. Now before you say anything, read the numbers on the left, 6, 4, 3. Read the numbers on the right, 6, 4, 3. Did the order change?
Yeah.
That is not commutative.
Something with order, so
No, order's commutative. Associative.
oh,
That is the associative property of multiplication. Now, let's talk about how we're going to remember that one. The associative property of multiplication. Okay? When I was a kid, my mom, I can distinctly remember her saying, "You are not to associate with that kid." Now, what did she mean when she said, "You are not to associate with that kid"? She meant, don't get in that group, right? Don't be part of that group. It's the same thing in math. In one side of the problem, these two things were grouped. On the other side, other things were grouped. That is associative. You're associating, you're grouping. Okay, got it?
yeah.
Okay, all right. Oh, P1 is done. Guess what that means? P1 is due on Tuesday. The P1 homework is due on Tuesday, and we are going to begin P2. All right, so here we go, P2. Oh. Well, you might have time. We might have time to get our diagram done in number 1. What do we call this? Quickly, guys, what do we call this right here? Which axis?
Y.
Y-axis. Label these, make sure you know the vocabulary, that's the y-axis. What do we call this one right here?
X-axis.
X-axis. Yep. What do we call this point right here in the center?
Origin.
It's called the origin. All right, everybody keeping up?
Is it negative? Oh.
Everybody got it? So far, so good?
Oh,
All right.
it's like A, B.
Now, what do we call these 4 sections? Quadrants. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4.
Do you have to do numbers, bro? Oh.
We use Roman numerals. Mathematicians typically use Roman numerals for the quadrants, and they gotta be in that order. You don't get to pick. Quadrant 1 is quadrant 1, all around the world. This system, this setup here, is called, anybody know what it's called? Anybody know what this whole setup here is called?
Plane.
It's called the Cartesian coordinate plane. And up until this course, you were allowed to just call it the coordinate plane because it's the only one you ever use. But there are other coordinate planes that we will discover. This is the Cartesian. Rene Descartes. All right, my friends. Thank you. Homework. Great class. try to be perfectly effective. One more class to go.
Design, one more class.